Hello, welcome back to our course about technology forecasting for strategic decision making. Today we are going to discuss the question, why do we need technology forecast? Do we really need this activity? Can we survive without? And why today the technology forecast becomes more on demand than it was in the past? In order to treat this topic, we are going to make clear what is different between invention and innovation. We are also going to discuss what is different between efficiency and effectiveness, and as well about limiting resources. The concept of limiting resources is quite important in order to be efficient, not only for technology forecasting, but for development of new technologies as well. So, if you just take point of view of technology management, the main function of technology management in an organization should be to argue when to invest on technology development and when to withdraw. And those main function stay on the core of the demand about forecasting. Because in order to take decision, this decision has to be taken precisely in time for particular market, it means in space, and about specific technology. But in order to understand how can we treat this decision with the help of forecast, let us first elaborate a bit more on the difference between invention and innovation. Today, those two words very often are used as synonyms when they are absolutely not synonyms to our point of view. Okay, if you look from point of view of process, we can see that the invention, this is a new working principle, okay, which is feasible and which show us the performance which is different from previous working principle. On the left part of this slide, you can see the new kind of transmission for the bicycle. It works, it is tested, and this is not something which was in practice before. On the right side, we can see the example of innovation. Here we have a production of new bicycles, and what is innovative in these bicycles, even from the picture it's not so evident, but this is an airless tires. It means with those tires you will never have a problem that you have a flat tire, okay, because there is no air inside. If you try to measure the difference between invention and innovation, the invention is usually measured in improvement of performance, like how many kilometers per kilowatt hour you can run, or another kind of performance measurement. When innovation usually is something that we run production, we sell on the market, and we have a return in terms of financial resources. Whenever we are talking about innovation, we are talking about production and profitability. When we are talking about invention, we are talking about feasibility and performance. From point of view of decision making and from point of view of technology forecast, it is important for us that there is a gap. Between invention and innovation, there is a gap, always a gap. And sometimes this gap is really very big in terms of years. To have a feasible concept, idea, even as a prototype, it is not enough in order to be successful on the production and to be profitable. For different systems, this time takes different time. If you look just to the history of basic innovation, those are the innovation on which our contemporary technological world is staying. we can see that, for instance, between invention of low-pressure machine, which essentially this is the core ideas of locomotive, which we used for the transportation of goods for the beginning of industrial revolution. The distance between two things is 55 years. 55 years we needed in order to be capable to build out of this invention, which was feasible, the innovation, the locomotive, which used steam engine for transportation of the goods. And this is an interesting question, why this is so long. Because the 55 years, if you look, this is at least one generation of engineers. If you invent something by being a student, and you have this duration between invention to innovation, it can take all entire life in order to see the fruits of your invention. In fact, one of the principal questions of technology forecast is to answer when, how many years it will take, and where this invention has a chance to be implemented. If you look to the history of basic innovations like high voltage generator, like pedal bicycle that probably most of you already have experience to use, and other photography, the production of cement, we can always see that it was a gap between invention, when it was feasible, possible to do, and innovation, when it becomes regular production. And those gaps sometimes very long. For instance, for the photography, the gap between possibility to make pictures and commercialization was 111 years. The forecast, technological forecast, has to be capable to clearly depict how long it will take. Because do remember, the very question which we are interested about is when to invest and when to withdraw. So, but how do we define basic innovation? Let us use the definition originally suggested with the book of Mr. Mensch, that a technical event is a technological basic innovation when the newly discovered material or newly developed technique is being put into regular production for the first time. Regular production, this is very important. Regular production, it means we have a cycle in which we produce, sell, and we earn enough resources in order to continue our production. What is interesting to see that for most of the invention, and I would like to underline that more than 95% of inventions, they do not appear as innovation. We have millions of patents, and out of them, more than 95% never become the innovation. What happens? Why it is like that? And from what it depends? It depends on many things, but we will see 2 or 3 reasons just a few slides later, because this is one of the essential questions that our forecast, reliable forecast, technological forecast for strategic decision, has to answer. Shall we put our efforts to the invention or not? Even it looks like feasible and very promising. Let me share with you another example of the beginning of industrial era in order to give you an idea how thousands of inventions have not appeared as innovation. At the beginning of era of steam locomotive, we used for the fuel the wood. Okay, in the 19th century in US, we had a very heavy problem, because if you use a wood for this kind of locomotive, you have a problem because wood cannot be burned completely. So small particles of very high temperature of wood goes out through the exhausting pipes and cause fires. You know, the wildfire in the forest, and in fact, all around the roads, this was a main danger and main problem at those times. So that's why many inventors, they try to resolve this problem. So 1,000 patented smoke spark arresters was suggested. On this picture, you can see just some of them. Different schema, and they were patented. It means, what does it mean, patent? Patent, this is something that entrepreneur, they have to pay for this document, because this document supposed to protect their intellectual property on the market. So it means inventors, they believed strongly that there will be some implementation. But I would like to underline once again, none of them was implemented. None of them. How it could happen? What happened? Why we did not implement them? Because when you start to use a coal as a fuel, you have this problem. The coal can be burned almost completely. At least you have this phenomena when the sparks goes out and cause the fire around the railroad. You see, in fact, even you have something feasible in your hand, we need to be capable to predict, will this feasible invention appear as innovation or not? And this is one of the very serious question for the technological forecast. The technological forecast has to answer. Let us see how do we approach today the question. Probably you already heard about so-called Gartner cycle. There is a question. Yeah, please, Vala. They have a question.
A question on so one of the this is completely new for me is that can patents or the knowledge captured in patents be an input for technology forecasting itself? So and where does it go as you know, in the methodology itself? Where would patents as an input for the technology forecasting exercise go? Do we start with that, or does it appear somewhere in the middle, or how does it go? I don't think I have ever discussed this with you.
In fact, the patents, this is kind of background information. Thank you very much for your question. The patents, they just show to what people are interested about. Because the patents, they show the strong intention of people to push their solution to the market. In fact, when we look through the patents, there are not so much knowledge inside, because the main function of patent is to protect intellectual property, but not to present. So the patent monitoring helps us to understand what is the temperature in a society about those topics. By themselves, unfortunately, the patents, they are not so good indicator to be reliable with forecasting. Why? Because the companies, they use different strategies. Sometimes the companies, they build the patent umbrella in order not to disclose in front of their competitors what they're working on. There are many different issues that are connected with the patents. The patents, it is not source of knowledge, but this is a source of information what people are trying to push on the market today. Okay, so this is a background. It's not input information, not output of forecast, but this is kind of background that we have to keep in mind. Like, you know, when you go outside, you at least interested about what is the weather about, you know, outside. Did I answer your question?
Yes, yes, I got it. Now I get it.
Okay, thank you for the question. Well, let's just try to see what today we can, some of the decision makers, they use instead of forecast. Okay, the one of the very famous idea which was suggested years ago by consulting company Gartner, a so-called hype cycle for emerging technologies, which indicate visibility of the technology. It means how many publications or how many patents do we have, or how many publications in scientific literature and non-scientific literature we have. And this Gartner hype cycle pretend to explain that any kind of new concept go through the several phases. Okay, the phase one, when we have a peak of inflated expectations. After that, the expectations start to decrease, the visibility start to decrease, and some inventions, they pass through this wave. Most of them, they don't pass, because the real implementation of the market, what we say innovation, starts somehow at the end of phase B, when we have slope of enlightenment, and when we have, for instance, on this slide, I share with you one of the very first hype cycle from 1995. And this, what we can learn from this, that in fact, the decision makers, they learn that they don't invest into technology because just it is hyped, because when it is hyped, it can soon disappear. And they don't miss it because it is out. It means we have to have something which will help us to put measurement on this time X. Unfortunately, even for today, we have no any time measurement on the hype cycles suggested for the different technology. On this slide, the emerging technologies for 2019, they put it, you can see some name of technologies like biochip. They are today almost on the top of peak of expectations. Some of technologies like autonomous driving level 4, they are less visible, but are they going to arrive to this slope of enlightenment and plateau of productivity? This is still open question. This is a still open question. So we need to, when we make technology forecasting, we need to clearly distinguish between differences. What are our expectations and what are the real capacities of technologies to answer today's needs or tomorrow's needs? Because will technology be on the market one day or another one, or how many years we need to wait until this technology will be on the market, depends not only of feasibility, not only it is possible, but it depends also on other things like, does it really solve some problems? How costly this solution? How long we need to learn in order to be capable to use this solution? Because the technology, this is a synergy of hardware, our knowledge how to design, manufacture, and use it, and the regulations that needed to run this technology. And if you look from this point of view to our evolution of the technology, we can arrive to the idea that in order to be reliable with forecasting, we also need to make clear what is the difference between efficiency and effectiveness. Because in new technology, usually the new generation provide us always better efficiency. You know, the engineered system, what is the difference between 20 years or 30 years old computer and the computer that you use today? It is much more efficient. It can perform much more tasks with the same power consumption for the same cost or even lower cost. Today's mobile phone, for instance, they are much more powerful than 30 years, 50 years old supercomputers. So, but let us make clear what is the difference between efficiency and effectiveness in order to understand why technology are evolving this way, not just through our expectations. If you took from the management science point of view, I do appreciate now it's become very classical, the definition that comes from great mind Peter Drucker from management science. He wrote that efficiency is doing things right, when effectiveness is doing the right things. And what is the difference? The doing right things, it's not absolutely not the same as doing things right. We will see the example. But if you look just to the emerging technology, most of the emerging technologies, they are struggling. They are always try to improve efficiency in order to be competitive with existing technology. So that's why we often, very often, we forgot about effectiveness when we are so much concentrated on the efficiency. Just to show you how it is serious, okay, let me see, for instance, the timeline of evolution of photovoltaic solution, okay, to generate electricity out of sun. And you can see that on this diagram, we see four big families, four big technological families, and the evolution within a time starting from 1975 up to now, according to only one criteria: what is the cell efficiency in a percentage? And you can see how many different solutions they try to compete on the market. And it is the highest efficiency, for instance, which you can see on this line. It doesn't mean the winner in this competition. But this is what happens usually in engineering world. I do appreciate, I do like to share this diagram with you also in order to answer the question that I received from students of mine many times when I showed them that between invention and innovation we have many years. Most of my students, they said, Dmitry, you are right, but it was in the past. Today, everything comes much faster. We have a reduced time between invention and innovation because we are doing it right now more efficient. But if you look just, for instance, for the photovoltaic, which is still not main source of electricity on our markets, even in a very sunny countries, it is still not the main source of electricity. We can see that the transition from invention to innovation started years before 1975, because from 1975, those are R&D programs which are heavily invested, heavily supported by fundings in order to advance with the products. And we can see that we already in this story more than about 40 years. 40 years already done. So unfortunately, with introductory course, we have no time to discuss the time from invention to innovation. But what I'd like to keep you aware that this time, even in modern ages, does not shrink. This time is decreasing and increasing, and it depends on the cycles in economy. because all technology, whatever we take technology, they serve some demand from economy. But now I'd like to come back to the difference between efficiency and effectiveness. And let us see this picture, this diagram, if you like, when on the vertical axis we put efficiency, and when on the horizontal axis we put effectiveness. If we are very high with efficiency, if we are doing things right, very fast, very low cost, very low energy expenses, in this case, but we are not effective enough, we just die quickly. It is just very fast process that we perform, but if the target is not adequate, we are not surviving. If we are very effective, but we are not efficient enough, we are always in a situation of surviving. We don't thrive. In order to be successful on the market, we have to be efficient and effective. We need to do the right things. And why it is not so easy to do the right things? Why we very often we are doing things that we believe that they are right, but at the end we don't see so much customers, or we don't see so much demand about technology, or we don't see so much context. Before coming back to this subject, I'd like to suggest for your attention the very short video, which is supposed to help me to convey this idea. What is the difference between efficiency and effectiveness? Well, such a situation is quite rare in India, at least in the most part of the country, but we are very familiar with the morning when our cars, especially in winter, when our cars are heavily closed by snow. But let's look together what happens. Yeah, he's working hard. And he's doing the best. But finally, yeah, he was very efficient, but not effective at all. We can see a lot of examples of such a situation when we work hard, we do the best to keep our efficiency at the best level, but at the end, this is not the thing that we have to do. So, in such a situation, he was quite efficient, but not effective at all. Another cartoon that I like a lot to share in order to emphasize the difference between being efficient and being effective. This one, the rabbit say, okay, we can go 100 times faster. But the question is not to be faster. If you are not effective, the question is not how fast you are going in this direction. If you are going in the wrong direction, it doesn't matter how we are efficient. There is a big question, which usually we use technology forecast in order to be effective. If we can answer how do we know what is the right direction in a technological advancement, we can be effective, not only efficient. How to be efficient, we learn during our education since the beginning. But how to be effective depends on your capacity to see the future. What will be the relevant technology to produce and to suggest from the market in order to meet expectation, in order to satisfy the needs of society? This is a question which helps us to be not only efficient but also effective. Thank you very much for this part of our lectures.